Welcome to Lesson 4 in the Mr. Circuit Lab on Digital Logic Gates. In this lesson, you will learn about the NAND Digital Logic Gate. A NAND logic gate can have as many inputs as needed, just like the AND logic gate. The one we'll explain here has two inputs, and therefore there are four possible combinations of input states as shown in the truth table. The first possible input combination is a 0 on input A and a 0 on input B. The second is 0, 1. The third is 1, 0. And the fourth is 1, 1. Remember that a 0 means a false and a 1 means a true. On a NAND digital logic gate, with only two inputs, both inputs have to be true for the output to be false. Otherwise, the output is true. The rule for the NAND digital logic gate is stated as follows. The output of a NAND digital logic gate is false only if all the inputs are true. Here is a practical example. Input A is, it is not sunny outside. Input B is, I don't have time. Output Q is, I will go to the beach. With a NAND gate, if all the inputs are true, then the output will be false. It means that if it is true that it is not sunny outside, and it's true that I don't have time, then the output that I will go to the beach is false. Here is the symbol for a two-input NAND digital logic gate. Look at it carefully. The symbol has a flat bottom and top with a curved right side. And it also has two input lines on the left and one output line on the right. It also has a circle on the output just like the NOT gate had. Building an electronic NAND logic gate. Here's a schematic diagram for an electronic NAND digital logic gate. In this Mr. Circuit Digital Logic Gate Lab, as part of your training, you will construct this circuit on a solderless breadboard. First, let me explain the circuit. You will notice that this circuit has two transistors, one LED, 4 resistors, a 9-volt battery, and two normally open push-button switches. As in all digital logic gate circuits, when the LED is lit up, it means that there is a true on the output. Let's talk about the transistors. Remember that when a transistor is forward biased, it means that it has the correct voltages on its pins to allow electron current to flow through it. Here we have two transistors. When you press switch S1, you forward bias transistor Q1, and when you press switch S2, you forward bias transistor Q2. In this NAND digital logic gate circuit, the engineer designed it so that the LED will light up as soon as you connect power to the circuit, which indicates a high on the output. The path of the current to light up the LED is from the negative of the battery, through the LED, through resistor R4, and then through resistor R1 to the positive of the battery. Note that the LED will not go out until you press both switches simultaneously. When both switches are pressed, you are forward biasing both transistors, and the path for the current is from the negative of the battery through transistor Q2, Q1, then through resistor R4, resistor R1 to the positive of the battery. No current will flow through the LED because the transistors are acting like a short circuit and there is no current left for the LED. Technically, The LED has the same polarity on the cathode and the anode, so it can't light up. If you do not press any switch, or if you press one switch at a time, the LED will remain lit up, which indicates a true on the output of the circuit. So as you can see from this explanation, this circuit works like a NAND Digital Logic Gate. Only when both inputs are true will the output be false. That is to say, only when there is a voltage on the input of both transistors at the same time will the LED turn off to indicate a false on the output. Now that you understand how the electronic circuit for a NAND Digital Logic Gate works, you are ready to build one as part of your training, following the step-by-step instructions in the Lesson 4 booklet. The world needs lots of people who know and understand these concepts and that can work with digital logic gates. Continue with the rest of the lessons in this lab so you can earn your certificate of electronics training that you can display and add to your resume. If you need to obtain this Mr. Circuit Lab 3, you can purchase it at www.mrcircuittechnology.com. We hope you're enjoying this lab and will want to learn more electronics. Thank you from all of us here at the Mr. Circuit Technology Company.